Hidden Layers. Meet the people behind the data with Uri Elabayev.
So, hi, it's a pleasure to have you.
Yeah, why not? Let's be here. Thanks for coming.
Thank you. Let's start with the introduction. Can you please introduce yourself?
Yeah, my name is Bill Jia. At Google, I lead a group called CoreML.
Mm-hmm.
So CoreML has two major functions. The function number one is so we work more on the infra side. Then the CoreML from infra side, we collaborate with Google DeepMind. We produce a Gemini model. Right, Gemini model. When design model, after model has been designed, we have to pre-train the model, post-train the model, and then run inference.
Mm-hmm.
So my function is I work with DeepMind all the way from model design, from pre-training, post-training, and inference.
Oh.
Then we help a Gemini model from research to production, eventually adopted by all the products like Google Search, Google Ads, YouTube, Waymo, and Map, and the Workspace, and Android, and the Chrome. That's one major function I'm doing.
Right.
The second major function is because Google Cloud with Google Infra, we produce TPU. Now, in the non-Google side, the GCP, and more bigger customers, they use TPU in very massive way. They actually use TPU for their model pre-training, then post-training inference.
Mm-hmm.
So the model is not exactly Google model. The data is not Google data.
Mm-hmm.
And the technical stack they use is not exactly Google tech, right?
Mm-hmm.
Because
you can choose whatever they want.
They choose what they want. So we actually make sure we have to make sure Google internal tag we can open source. So hey, you know what? We open source this tag, so you can use this open source tag to run your model training and post training and inference.
Mm-hmm.
Or you use the existing open source solution like PyTorch.
Yeah.
I use PyTorch and whatever Python ecosystem TPU.
Mm-hmm.
To work with customers, make sure they have very tactical, faithful routes to make the model from research production become very successful. There are two major functions.
Oh, each of them sounds really interesting. Let's start with the first one.
Sure.
I would like to talk with you about the design of you say you are working very close with DeepMind on each of the steps. And I would like to speak with you about the first step. How do you collaborate when you're just starting to design maybe a new model, maybe a model for a specific task?
Yeah.
So they do their job, do the research. Let's work together and collaborate to make it at the end, let's say research that can actually get all the way to production.
Yeah, that's actually a very good question. So whenever we design the next generation of Gemini model, we're using Gemini 3 as an example.
Mm-hmm.
So about 9 months ago, we start to design the Gemini 3 model.
Mm-hmm.
The 3 model, of course, right now released, but just a retrospect process. DeepMind say, hey, you know what? I want to design the Gemini 3 model. Then they look at the latest industry state of art. They need to go ahead of the state of art. Otherwise, we'll be falling behind, right?
Yes.
So, okay, our model will be largely this shape. But we design the model largely this shape, can infra provide all the support. Mm-hmm. So how the TPU looks like, and how the networking looks like, and how the training software looks like. Mm-hmm. Then, hey, you know what? Let's consider all this in one place, so that model design and all the networking and all the training software and all the hardware can be co-designed together. Okay, that's actually our collaboration. After we co-design together, when the real training start to happen, then we collaborate very closely. So, hey, you know what? It's everything co-designed. Is everything going smoothly? Because no matter how co-designed we are, during the training, the co-design actually really challenge the state of the art. Mm-hmm. Our pre-training scale is 100,000 TPU in one training cluster, run out one training. That's actually really touch the state and push the envelope. But if we push the envelope, during the real pre-training process, that takes like weeks and months. many things can happen.
Yeah.
This TPU will fail. This network got congested.
Recovery.
Yeah, how to make sure that everything can go as smooth.
Yes.
As a matter of fact, internally at Google, we use one metric called good put.
Yeah, good put.
Good
Yeah,
put,
I
right?
remember that.
Because then
Yeah, throughput and good
everything
put.
is throughput, but even throughput is not productive. Let's say we checkpoint, right? We checkpoint, hey, you know what? But then something happened. You have to rewind
Yeah.
the process to the last checkpoint. Then reinitiate, then rewind. Feels like TPU is very busy, but not something very useful, not going forward, right? So that actually not considered as good put. That's throughput, not good put.
Yeah.
We measure good put, and we really want the good put as high as 95%, even though training skill is very large. So that's one example that we work since very together, very close together. Then at the end of if I become pretty confident, hey, you know what, this model is actually very promising, then we're pretty confident this model eventually is going to work. Then even before the model finally is finished, training finished, we're pretty confident the model is
you have this understanding that it's going to work.
Then we take the models without wait for the final weights to be finalized. We start to work on all the inference optimization.
For the serving.
For the serving, right? For the serving. Because the serving model architecture is already fixed. It's just weight is not fixed. But then we can do a lot of like auto sharding and the disaggregated servings and all the
So you need optimization even before you finish to train the model.
Yeah. So that then we gain a lot of time. Then after the pre-training really finished, most of the serving optimization already done. So then, model is very high quality. Okay, serving almost ready. Then we can release very quickly.
Wow. So it's really interesting, the collaboration. And I want to ask you maybe a tough question.
Yeah.
Can you give me an example for a trade-off that you are doing while you are working with the teams?
Yeah.
Because I guess sometimes they want something different that you want.
Yeah.
Maybe sometimes it doesn't make sense. So can you give me like one example of things you are debating internally?
It's very good question.
Thank you.
Our research work, their primary concern is my model is state of the art.
Yes.
Right?
They want to hit the benchmarks.
Yeah, hit the benchmark. And also, hey, hit benchmark is really good, but working 90%, very high quality. Bingo, that's good. 90% of state, it's very good. But then, we're going to release it.
Yes.
But then as an infra org, I work with all the product teams. I'm like, hey, hold. 90% good is not good.
If we Google scale,
you will release this model to search.
Yes.
Let's search overview, search AI mode. Let's AI overview AI mode. If you just say, hey, I run 10 queries, but one query is really not very good quality. I don't care that nine queries is very high quality. One query is very low quality. This product is bad, right?
Yeah.
So hold on. Let's slow down. Let's investigate, and let's think about how to improve. But that takes time, right? So sometimes the tension coming from, hey, you know what? Let's move very fast. Then we touch the research, like the cutting edge research. That's good, but on my side, infra side, product side is like, that's what we need to make sure every single query quality is good, reliability is very high, efficiency is very high. In other words, that's research, it's innovation, it's the state of art. And for production, it's high quality always, reliability, performance, and efficiency. Right? These two things are typically many times are on the same direction, but many times are into opposite directions.
Yes.
But that's then to work it out. This one thing I really like Google is we actually had a global picture in our mind. I was like, hey, you know what? A DeepMind leaders in DeepMind, if I'm in your shoes, I totally understand why you want to do it. You understand. If I was in your shoes, I would do the same thing, right? But hey, you know what? Cora and Demise, if you are in my shoes,
what would you do?
You will also do what I'm doing right now, right?
Yeah.
So let's just share the mutual perspective. Let's reconcile. So very much we say, hey, you know what? Let's have a preview stage. So then you can release all your products out, but in a preview.
Yeah.
So the research community and the industry get very enthusiastic. Oh my God, this model is really good. Right? But hold up, we're in the preview, we're in the alpha beta, not production yet. Then so the entire industry get very excited, which actually research team really care about. Then we also take a little bit more time to like strengthen and fix all the residual issues. So we actually always find out middle ground. And we also say, hey, what in order to move very fast, let's have a entire process, infrastructure process to within 7 days, within very short time, let's go from idea formation to prototyping to experiments. This needs to be very, very fast.
Well, 7 days.
Yeah, 7 days because it's a fast pass. Right? This let's kill all the barriers along the way. Now going to production, we call the production pass. Production pass is let's just imagine all the production issues. Let's fix all the issues. That takes a long time, but that's fine. Right? So that's the way we have always found the middle grounds.
Yeah, it's fascinating. I want you mentioned production. I want to ask you about this cycle because sometimes when you get out there, let user use the technology.
Yeah.
Especially in the inference perspective, sometimes understand that you need something model that is much more faster. Let's say we have the model that fast, light, or maybe sometimes you don't need that heavy lifting model that will do all this tough work, but you want it for specific tasks.
Yeah.
So how does the cycle work? Basically, you release it, you get feedback. Does the DeepMind can actually make some changes? Or sometimes you say, this is an amazing model, but it will be too expensive to run on inference.
It's actually very good because it's actually it can be very deep discussion because there's so many techniques we use. At the very highest level, when we build models and we provide feedback to DeepMind, hey, you know what? The model is very, very big. It's 100 billions or trillions and tens of trillions parameter, right? But that's during the training stage. But all the trainings has so many different experts. Then during the production, during the inference side, only less than 10% of parameters actually got activated, right? Depending on the queries. If the query is this type, then we detect, we say, you know what? This portion of model got activated. So that actually makes the model, the de facto model running survey much smaller.
Yes.
For every single query, right? So that's one. The second one is even we always use that technique, but we also quantize model.
Yes, to shrink
very, very much quantize model. Distill the model. Okay? Do all this. Then that also shrinks the model size. Not only only less than 10% parameter got activated, the model size also becomes smaller. Then we also talk with product team quite a bit because no matter how we do this, eventually that's still this MOE models and the good in everything models work in production. So you know what? Product team, what do you care really? Some teams search.
Precision, recall, fast.
Because for search say, you know what? I don't really care about the coding. Nobody in the Google search box doing the coding work. I need summarization really good. I need certain time maybe people ask mathematical questions in the search box, right? I need only these functions. Can we produce models that are smaller, but really good in these several functions, not all different functions? So that's also we Simba provides specialized model for certain function only.
But we have the same origin model, and then you specialize a specific test depending on the product needs.
Yeah, there's several different ways. One is the model. The model is the foundation model of the foundation model. We do additional training with the vertical data sets. Right? That's why sometimes we just build a foundation model. This foundation model is very specialized, just for this only. Then in that case, the architecture will be a little bit different, and the build towards those functions specific.
Wow, you're really interesting.
And we also nowadays we also feel the on-device model. The on-device model will take on more and more dominating role in the future.
Can you define this? What does
Yeah,
it mean?
because on-device model is all the model running on the cell phone, model running in the car.
You're referring, for example, Gemma 4, 2, and
Exactly.
4B?
Exactly.
Oh, all right.
That's we feel like the model size is still the same. The size like 1B, 2B
Yeah.
parameters are same, but the quality become much better.
Yeah, I've tried them at my home. They are amazing.
Yeah.
The 2B, the 4B, if you can actually make them for a specific task,
Yeah.
they are working really good. But
Yeah.
I want to ask you, it's interesting that you mentioned, but are you looking for those kind of models as an endpoint for this entire computational, let's say, journey? Because sometimes this is my question, do you take into consideration that maybe some of the tests we can offshore to local models, or we just said, okay, we just need the model in the cloud? It's like a more philosophical question.
Yeah, that's actually a very good question. So that actually the reason I mentioned ODML. OD represents on-device OD, ML, that's machine learning. So we make the on-device model a lot better. And this model directly running locally on the on-device, on the user's fingertip. So for a lot of queries coming in, I mean, regular people, many of the users, I generate queries. Hey, you know what? Doing Google Next, doing dinner. Where should I go dinner? 7 p.m. That's a simple query because there's all this many restaurants. It knows my personal taste. Recommendation is very simple. Right? This query is very simple. For this simple query, many people's actually day-to-day queries are quite simple.
Yeah.
So those queries can be served on-device local model perfect file. Okay? The quality is just really good enough. But if the model is more sophisticated, hey, and the query is more sophisticated, you know what? I want to have a dinner with Yuri, and Yuri coming from Israel and from then
you need the kosher food, for example.
Then kosher food, and we're doing food. We also want to have very quiet environments, and we cover serious stuff. And we're friends. We're talking about compare notes on how to raise our kids. Okay, complicated enough. Then the local models not good enough to provide high quality models. Then we fan out to the data center. So I believe the future AI survey will be a very hybrid, partially on device, partially go to cloud. Right? But on device, you can do a lot of queries. A lot of queries are simple enough.
Yes.
I think a large portion of queries can just serve on device.
And it's also more secured.
More secure, and you can latency and security, and you can have a lot of personal data on device. I actually don't care. So if my personal data is not on the cloud, then all my activity on device, I would love to save locally. Okay? Yes. And that we have this conversation. I just check this email. I check this food. All this context that can be saved on device. That's all my personal characteristics. Then when I do the Google search, then all this context can be used as inputs. The search results be highly accurate. That's beautiful.
Yeah, that's true. This is like the true meaning of personalized.
Yeah.
It can get more personal than that.
Yeah.
But that leads me to the other question. In the infrastructure way, how do you know how to, let's say, do those offloads to local? How do you prioritize? How do you make this filtering? You know, so my question is because some of the magic is to know what kind of task or what kind of query needs to go to the cloud, what can be solved locally.
Yeah.
So you need to be very sure on what is the task, the quality of the model, the history of the usages, and then to do it in a blink of an eye because there is a one way.
Perfect question. I think so model so the query analyzer then based on analysis results serving local or serving to cloud. That analyzer itself can be an AI small model, very small AI model.
Yeah, like a classifier of
because that can be learned, right? This because let's say initially we force all the queries are served locally. Right? And some queries, I love this results. Good. Some queries are just not good enough because the query is too complicated. But if the results not very, very good, I will have different response. I will say, hey, you know what? Hey, Gemini app, the results not good. Can you give me another different results? Can you give me another different results? Then based on all this data, the analyzer model can be learned, can be trained. Right? Then eventually we can run a very small model, the model's analyzer. Queries comes in, look at query, the decision, the output is serving locally, serving on the cloud. Even on the cloud, we have a flashlights, a flash, a pro. We can also do further separation.
Routing.
Yeah, routing.
Yeah, I want to ask you more question.
We have like 2 or 3 minutes left. Sorry.
All right, so last question. We're enjoying that. I enjoy it.
I didn't realize time going
Yes. So last question.
Sure.
Now we see new usages of multimodality,
Yeah.
videos, images, audio, sensors.
Yeah.
And you also see new usage of agentic that they need to do more. It's not just a token, it's calling, MCPs. It's how does it affect the infrastructure or the TPUs or the workloads and everything when you design and also then in production?
Yeah, I think so. I think on the training, it's a very good question. On the training and on the inference fronts, I think that makes perfect sense to separate the chip type. So that's when we TPU 8, generation 8, we have T and we have I. Right? T for training, I for inference. Then training and inference, then the diffusion and the dense model, then not a mix of experts. They also have certain kind of different characteristics. Then, so for now, Google's philosophy is using one chip to do all the work. If you use one chip to do all the work, you would imagine, hey, diffusion model and dense model and the MOE, they will have different characteristics. Then if the chips are all same, then there's certain capability of the chip will be wasted.
Yeah, the trade-off of
for sure. Then that we do a lot of software investment. That actually my group are getting a lot of software investment. In other words, let's these models, let's run all the training and all the inference are distributed and the parallel. We actually do a lot of sharding and pipelining so that we can reshape the model in certain ways. Then networking, memory, bandwidth, storage, and the compute not waste too much. That's a lot. The software can be very flexible.
Yes.
We organize this in many flows.
Thank you. Fascinating. Yeah.
Yeah.
I hope we had more time. Yeah, but sounds really good. No, it's all good.